Yeah, how's it going everyone? Smo here. In this video I'm gonna talk about that one of the bugs that in the first place, in the first sight, it would look completely impossible to solve, especially like if that was or this is like the first time you hit this type of bug, but it's actually kind of obvious once you understand the reason behind it. So also it's like this type of bug is super expensive. Like for example, if you have an AI agent and the AI agent would cause you like to charge the customer 3 times, and now that customer is in your inbox, etc., etc. Who knows what's gonna happen later? You already know. Yeah, so it's so super expensive. Now let's talk about the setup of this type of bug. The setup is actually, let's say for example, you have an AI agent or maybe multiple AI agents, and these one would do something in actually the real world. Let's say for example, charges a customer credit card, sends an email, books a meeting, writes a row in a spreadsheet, and somehow this AI agent or AI agent team would do that thing twice or maybe sometimes even 3 times or more. And for this type of issue is like the part that messes you with your head a lot is when you go back and check what actually caused this, you would find no error. So basically nothing crashes, everything the log looks green, and so basically what you do is like you go check again, and there's just like two charges or maybe like more charges sitting there, like the agent run the same thing more than one time, and the issue is just like staring at you with no actual reason the first like that you can actually see here. And just like maybe let me be honest with you here and just like save you a lot of time and resources. So basically, because I've seen this a lot happening with like almost like 9 of 10 of people who would have this problem, all they would do is either blame the AI model. So they would say like, oh, maybe we need the smarter AI model with more parameters, or they maybe say maybe we have like a bad prompt and we need to do more prompt engineering. So let me save you both time and resources here. This issue have nothing to do with either of these. So yeah, it's neither the model, it's neither the prompt here, and I'll explain exactly what's caused this exactly and how you can fix it. But before that, you may be asking like why you would be listening to me in the first place. So if you don't know me, I've been building like mission critical systems across industries for the last decade. And basically that's what I do for a living. I diagnose, I fix, I scale mission critical systems where in like different type of industries, where like for and also I work. Basically, I run my own consulting firm, and we work from the model to the metal. We across all the layers of the system, and that's what we do for living. And yeah, basically I've been seeing this bug again like multiple times in different type of systems, and basically that's the pattern that I'm gonna share with you here and how you can fix it. So without further ado, let's get started. Okay, as you can see here on the screen, so what you have here is basically the shape of the whole problem here. So in one picture, let's say on the left, that's like your client or maybe like your AI agent. So all it did was just like ask for one thing, one credit card charge, and on the right is actually the thing that actually happens, uh, actually like happens out in the real world. So as you can see, there's an action, travels across, hits the side effect. So for this one, a card gets charged. That's perfect, and that's exactly what you want in the first place. And then taps again. So a second copy of that same action comes through behind it, and it fires again. So what ends up happening is the same charge would happen twice. And here I want you to notice something that like nobody asked for a second one at all, just like showed up from nowhere, or at least that's what you can see in if you look just like on the surface level. And this is like right here is the whole bug in just like one line. This summarizes the whole issue here. So you intended doing one thing, the system executed two things, or maybe even more, and I really want you to sit with that gap for just like for a second here, because actually it's so different. It's like different kind of problem than actually it looks like. Because this is the wrong thing. Because this type of problem is not like about the wrong thing is actually running. It's actually like because the action was actually totally correct. It was the right thing, just like was running twice or even more. So the question here was never why did the model mess up. The real question is what came through and what came through for this type of system that made the model run this thing twice or even more. Okay, so and I feel like when this happens for real, here's what you're actually staring at. So you meant for one thing to happen, one charge, one credit card charge, or like one email to be sent, something like that. But what ends up happening is like two landed, like two credit card charges, same amount, just like few seconds apart to the same customer. And here's why like this one's so nasty compared to a normal bug in the system, because there's actually nothing broken to go to find there. There are like no exception, no stack trace, no red in anywhere in the logs or the code. Basically, like everything worked perfectly on the surface level. Only thing is like just worked twice. So basically, you cannot just like debug it like crash, because as far as the system's concerned, nothing went wrong. Just like did what it was told to do, but just like did it more than it should have done it. Like basically did it many times than what you wanted to do. Okay, so now let's kill the wrong instinct right now, because actually the thing that sends everybody down the rabbit hole here. So the model would ask for one action, like one time, and for this case it's always like would ask correctly. So that part was never the problem in the first place, as I told you earlier. So and I want you to write that down. And for the second execution, it just like happened after the model was actually done already. So the issue is actually somewhere in the machinery that takes the model's request and actually carries it out to the next thing. And just like the drop tool call from the last video, that's the part that nobody ever looks at, because it's not the shiny AI part here, but it's actually like the exactly where and that's exactly like where this bug actually lives here. It lives in the trenches. So I just like want you to quit staring at the model. It's not about AI here at all, and we're gonna look at the actual plumbing and what actually caused this issue to happen in the first place. Okay, so if you actually want to really get this issue and why it's actually happening in your case, you've got to understand what retry actually is, because it's not what most people actually picture it to be, and the cleanest way is something that you've literally done yourself here. So let's say for example you're buying something online and you hit pay. So tags, so did it work or not, and just like spins, maybe a couple seconds go by, nothing, and now you're just like you're sitting there like did that go through or not, and I generally can tell this at this specific moment. And then so what you do, you click that button again, and because that's the obvious thing anyone would do here, because everyone would do that. And basically if that first click actually went through, then congrats, you just like paid twice. So and here's like the whole thing, like the only thing standing between you and double charge in this example is actually whether the site is smart enough to look at your second click and just go and say this. So hold on, I've seen this one already, this is the same payment, not a new one, so don't recharge this dude again. That's the recognition. That's the this part of the system that if it does not exist, you would get charged again. And just like that moment, that small moment of like, wait, I know you, that's like the entire fix for this whole video in just like one sentence. If you can get anything from this video, just like understand this point here. And honestly, like most of the times, I've seen like many smart teams that never even check never even get concerned about this thing. So what ends up happening is they would never build this in the plumbing side. So I want you to remember this point. And now let's move to a different example, and just like let's take the human clicking twice from the equation. And for this one, let's put an agent system instead. So the thing that would be clicking twice here isn't actually a person, it's actually your own stack, and just like does it in 4 different distinct ways here. I just want you to watch these. So, oops. So the first thing is like, it's the network. So what you would have is like a retry request that never got an answer to. Second thing is it's actually queue, which is like redelivering the same message again. Third thing is actually your orchestrator. So basically it would rerun a step that looked like it failed, although it did not fail. Fourth thing is maybe it's the agent itself, just like loop it and asking for the same thing again and again. So these are the 4 different reasons of why the AI agent systems would do that. And every one of these is actually doing the exact thing that you did on the payment page. It's just like basically if we get it back to first principles, what it does just like it's clicking again, just like clicking again for the payment. That's it. And the reason that they can't help it is like and also like the reason why this actually a little bit difficult is on the next slide of this one. So because like not one of them can actually tell whether the first one worked or not. So let's move to the next slide. And now let's actually slow way down here, because this is the heart of the whole thing. This is like what you should understand in order to be able to diagnose your system and understand which of these cases is your situation, and then how you can actually fix it. And if you can get this idea, the rest of everything will be super easy for you. So I just want you to focus and stay tuned here. So your request would goes out, and here the server would actually does the work. So the credit card charge, for example, would go through. So by that time it's already done, like for real, like the money already moved, the transaction already done. But then what happened is like the reply, that little message coming back saying, yep, that thing worked, the payment passed by, just like get lost on the way home. So maybe like network hiccup, timeout, whatever reason. So now I want you to put yourself where the client is standing here. So all you know is you didn't hear back, and here's the mistake that everybody makes here. Like, think about texting someone and your phone never showed like message delivered or not. So you would be asking like, did they get it? Did they not get it? And basically you have no clue, right? So a timeout is the same thing here. It does not mean it did not happen. It just like means that you have no idea whether that action or that thing that you're waiting for happened or not. And look at like your 2 options here. Like either you're gonna try and actually did go through, or just like either you're gonna try and just like actually just did go through, or just like gonna do it twice. So that's like the first thing. Second thing is you may like need to retry, and because it actually failed, that way you'd fix the problem. So basically like these are actually the same action, but each one would have super different outcome, especially in a mission critical activity or something that cause like real world damage for your business. So in other words, like retry action is actually coin flip 50-50. So that's literally what is it. half the time you're saving the day, and half the time you're actually double charging someone, or maybe that even like would cause like a whole suit like a lawsuit comes to your business, or even like losing a key customer, stuff like that. So yeah, that's not something to just keep it for chance. And basically, like, because of these type of actions, you don't want to leave them to chance or probability here. You need to be 100% sure that it was either first one and it already delivered, so you don't need to retry again, or it actually failed. That way you need to save this to save the day. So here is it, like this is like the one line that I want you to walk out of like this video with. Retry is not a second chance, it's actually second execution. So like that's block one, I just like locked in here. Retry is actually second execution. Now let's move to the block 2 of this video, which is like where do these doubles actually come from. And turns out like there are 4 doors, and let's walk down each of these different doors. So here's like the whole map here. On the right of the screen, as you can see here, this is like the side effect. What that means is like the thing that actually gonna happen, and in front of it, like see that empty slot here, this dashed one. That's where your actual gate should be. Basically, a gate is just like there to catch duplicate and just goes already seen you just like right now, and there's nothing there. So I want you to hold that thought. So door 1 is actually retry. Retry, let's say for example from the client or the framework itself. Door 2 is redelivery, which is like from your transport, or maybe like a queue or webhook. Door 3, which is like a redispatch, which is from your orchestration layer. And door 4 is like straight double trigger from maybe an input side. And here's the idea that actually ties this whole talk together here. So I want you to lock it in. So double needs 2 things at the same time. Duplicate coming through one of these 4 doors here. This is like the first thing. And that missing gate. We need like having both of these in the place. And just to be crystal clear, none of these those 4 doors is like the model being dumb here. Every one of them is actually the action was correct. It just like showed up twice. So I need to repeat this point again. Bigger, smarter AI model won't fix this because it does literally nothing here. It does not have any input on these type of issues. So let's walk the doors and start by talking about the most common door going down. Yeah. So door number 1 is actually the retry one, and the one that we just like talked through. So let's just actually get into the mechanism of, because you need to understand how this actually works, not just like on surface level, but how actually this works, so you can prevent it from happening. Or even if you're not a technical person in the team, at least you can guide your developers team or your technical teams in order to solve this problem. So here's what's happening in under the hood here. Okay, so the setup is that crux we just did. So the request was committed, and the reply gets actually lost here. So what ends up happening is like your client would fires the charge, and the server would actually commit it. So money moves, transaction done, and that's already happened. But what ends up happening here is like the response with the times out, maybe client never hears back. So what ends up happening is like the client would just like retry again. It would just like fire the same charge again, and boom, just like get double charge. That's like the issue here. Now, here's what I actually really want you to notice here, because for this specific type of issue, or this door here, like the retry door, did not send the wrong charge here. It's just like sent the same charge twice. And two things make this actually a little bit harder than what you would think it is. One is like most of those like SDKs retry twice by themselves, like that's the default state. So you maybe like you even like you probably didn't seen that at all, just like there, just like sitting there and not on surface level. So it's not something that you can notice right away. And number two is like when they actually retry again, they will just like rerun the whole step again. So with the actual side effect included in that. And this is like, yeah, basically like now I want you to look at something which is like something that I want you to feel like if this feels familiar for you or not. Which actually it should be, because networking people have been fighting this exact type of system, like bug in the systems, for decades now. It's not like something new in AI models or like AI agents or machine learning or any of that stuff. This thing, like this type of issue, been existing for decades now. Okay, so you can understand that you need to go and understand a little bit about like networking people who are building systems and work in this specific space. So for them, this is this is just like TCP, say like the same bug, just like one layer down. Let's say the metal layer, not just like the superficial, like the high level AI stuff. Just like down to the metal stuff, because it's been happening for decades now. So let's say, for example, when TCP sends a chunk of data and doesn't get an acknowledgement back. So what ends up happening is it's just like with its room, it get lost, and it will just like resend it again. So this is like the same exact move. I just basically the move is I didn't hear back, so I'm gonna send it again. And here's the actual elegant part here, because like every byte carries a sequence number. So when the same chunk shows up twice, the receiver would just like looks at the number and just would say like, this is duplicate, let's drop it. There are no harm here. And that sequence number is actually doing the exact same job as like an idempotency keys does like at the up layer here. Basically same failure, same fix, just like one layer down to the metal side. That's the whole problem. So this is door 1 finished. Now let's move to door 2. Now for door 2, it's actually about delivery here, and this one actually trips people up, because it's not a bug actually. It's actually a guarantee doing exactly what's actually what it was promised to be doing in the first place. Okay, let me show you. And here's a way to think about this specific problem. So imagine a mail carrier who's been told this thing. So if you're not like 100% sure you delivered it, then you need to deliver the mail again. So what ends up happening is like sometimes we just like get the same letter twice, and for this case the carrier was not messing up. He was just like literally doing the policy that he's been asked to do. So for that's your actually queue here. Queue is for example like a webhook, an event bus. It will just like deliver the same message more than once, and that's actually that's like the policy, that's how it actually should perform here. That's the purpose of it. And this thing is actually called at least once. This is type of policy for these type of frameworks or tag here, and it's basically built on the premise that these systems would make, which is like if you're not sure you delivered something, we need to re-deliver it again. That's the whole premise of these type of technologies. So now let's say the message would comes in, it would get processed, and then it comes in again, and you can literally see it here, just like right there. So what ends up happening is actually your receive count here is actually 2. So the system here is straight up telling you, hey, this is actually the second time I'm handling you this one, and basically like every time it gets delivered, your handler will just like charge the card again. So get this point straight here. So the redelivery is not the problem here. The redelivery is actually guaranteed that, and that's what you signed up for by using the specific type of technology like webhook, something, or event bus, stuff like that. So the problem here is a handler that was not safe to run same thing twice. That's the actual problem here. And again, so the protocol layer solved this age ago. This is like problem been existing for ages now. It's not new for AI. So let's go down to the metal layer. Let's go way down from just like the application layer, the higher surface stuff, and understand how this been solved in more complex scenarios, so you can understand how you can fix your system better. So for this one, so basically HTTP literally tells you which operations are actually safe to repeat, and which ones were not safe, and actually it's baked into the spec. So basically, if you ever worked with any HTTP request, or yeah, basically you're gonna see these types of things like get, put, delete. Those are idempotent, which is just like a fancy word for saying this is actually safe to repeat, and you can actually do it again, because like nothing new happens. But for request like post, it's not. So for do twice, you may actually make 2 of something. So you need to be more careful. And for that reason, like when you need to do a post, and you want it to be more safe, which is exactly like the credit card charge twice type of scenarios that we talked about. What you actually do here is you would attach an idempotency key, and here's the actually mental model for this thing. So think about this as like a code check. So you hand over your code, and what you'd get instead is like a ticket for, let's say, ticket says 47. So if you walk back and hand them the ticket with that number 47 again, they would give you your token. They would give you nothing because because they didn't. So basically, like sorry for that. Basically, like if you go back again, and let's say you give them that, and you try to give them like the ticket 47, and they, for example, let's say they didn't take it from you and give you the code, and then you give them the ticket again, they won't give you anything because you already got the code in the first place. That's the example here. So the key is the actual ticket here. So the server would seize it again, and hands back the first result instead of charging you more times. And that's here the same idea, just like one layer down. And now let's move to door 3. And honestly, this is the one that wrecks agent systems the most. So let's look at the next one. As you can see here on the screen, so door 3 is a little different from just like simple plain retry, and here's a way to picture it before we even like look at the trace. So imagine you're doing a long task at work. Let's say, for example, that task would take a while for you to do it. So and let's say like your heads down. Now let's say like your manager doesn't hear from you the whole day, and he just like assumes you bailed, you didn't do any work that day, and just like hands you the same task, the same task that he gave you to someone else. And the thing is, like in that case, you didn't bail. You were just like focusing super deep, basically like you locked in to solve to do that task. Now what ends up happening is like two of you are doing the same exact job twice, and that's this. Just like watch here. So you've got a tool that let's say like a tool call that takes a while. Let's say a couple of minutes, and let's say for example big scraping, long generation, whatever type of task. And you would have like worker A, which is like would be running it, and it's actually gonna finish fine. Just like takes a little bit of time. And now let's say like sweep would redispatches the same task to worker B, which would be running at 2 now, which is like here in red. But here, like while it's actually running, lease or maybe like heartbeat expires. So the system here would go with like, this worker actually must be dead by now, and he would just like redispatches the same step from checkpoint. Except for this case, the original one didn't die. He was just like it was just like slow, doing something, but a little bit slow. So now you've got like two workers running the same thing, the same step, and let's say both of these systems would finish. So what ends up happening is like 2 to 3x the work needed, as you can see here. Here's the actual kicker here, because this isn't actually a retry in the first place, because like nobody ever retried anything here, just like timer expired underneath slow step. And this is actually like a super real documented issue, and it's not about this like actual number is actually live one in many major frameworks. And it's not just about software here, or like super level, like high level apps. It's actually way down to the metal side, and even like the metal side had the same issues, like the same ways, and people been trying to solve it for decades now. So let's learn exactly how they solve it, so we can understand how we can solve it for our more simpler situation. For this one, for if you go like down at the hardware level, a command on a bus like I2C or maybe can would just like guess resent when there's an error. And whether like that's safe, safe comes down entirely to just what you're actually writing. And this is the cleanest way to actually understand idempotency. And honestly, like I want to think about your maybe thermostat here. Yeah. So let's say for example you're gonna set your thermostat to 72, and you're gonna do that twice. So actually you're still at 72. Were no harm here. Let's still write an absolute value, and that value can be here like set this register to 5. So resend is just like just like lands the same 5, and that's totally safe. And now let's say if your actual request is turn it up by 2 degrees, and if you're gonna do that twice, what you're gonna say, and what's gonna happen is like you're gonna sit in there sweating, right? So fucking hot. That's like writing the increment part, or maybe like clear on right by a bit, or maybe like push into a FIFO. That's like a resend, which like the double counts, double clears, double pushes, and that's the actual problem here in a nutshell. That's like the same exact question. That's like right down to the metal, and basically it comes down to, is this thing safe to run twice? Yes or no? Now let's move to next door. For this one is actually the simplest one, super easy to identify and fix. So basically, let's say we're gonna have like the same call just enters the same system twice. So as you can see here, so we're gonna have like two copies comes in. Let's maybe they would have like milliseconds apart with different IDs, and this can happen like two ways. First one, sometimes like this can be like flat out framework bug. This is super common. Many frameworks have this type of issues. So let's say for example the tool function literally gets called twice, and the issue number is an actual double invoke here. And sometimes it's actually the model itself in this situation. So maybe the AI model re-emitting the same call inside the loop with the same arguments, just like it will give it a different ID. And honestly, like either way, nothing on the path recognizes the second one was actually repeat of the first one. So your database layer, by the way, like your database layer is actually gonna rejects this kind of thing by default if you just like let it. And let's say if you try to insert the same row twice here, the what's gonna happen is the database has your back if and only if you actually set it up right here. So if you're gonna put like a unique constraint on this one, so this is how you're gonna solve this simple issue. If you're gonna put a unique constraint on it and just like use an insert on conflict, that would create like the row like second does basically like the second one would does nothing, or maybe like just like rolled up throws 2 3 5 or 5 something like that. So basically like first insert row gets created, second insert of the same thing database just like goes and basically tells you like nope, already got that one, I don't need to create it again, and it will do nothing in this case. And if it's just like didn't guard it, the row duplicate can throws a unique violation, and that specific type like error code was right there. You can like include it in the code so you can study if that type of situation happens. You can fire special methods in order to handle that. And the keyword here is like the one that comes back in the fixes is that database decides the actual winner in one atomic step. We're gonna use like in one operation, and I want you here to hold into atomic. Okay, so those are the four doors here. And now here's the thing that decides whether any of them actually hurts you or not. So this is the most important slide in this whole video here, genuinely talking here, because everything up to now was set up for this one. So I want you to stay with me here. Okay, so I want you to look at the boundary, like right before the side effects fire, and look at what's missing here. Here's the actual trace. The agent run reports success. That was green. Now the model spans shows it intended one call, so one. The tool would run, and then it would run again. So two executions so far. And here's like the whole point here, like nowhere, like anywhere is nothing comparing the model one against to actually ran. And the reason that like there's like no gate, no idempotency key at the boundary, and no check afterward. And this is like the hinge of the entire thing here. So let me just like say it flat out here. This is why all like the four of these doors actually will gonna hurt you, or actually this is what's gonna determine if any of these four doors are gonna hurt you or not. So if you're gonna take any of these doors that we talked about, let's say for example, like if you're gonna take any of them, and if there were actually gate right here, the duplicate would just like gets caught and nothing bad happens. So but in case if you're gonna take the gate away and every single door turns into a double charge, that's catastrophic. So basically what I mean to say here, and this the critical point, is like all the doors are super common. That's super be assured of that. But the missing gate is what makes them actually dangerous. Having missing gate, you should not even like worry about these ones. And I want you to get this point. There's like one whole layer of computing that made this gap basically impossible to happen, and that's actually on purpose. And again, this layer have like no AI model in it at all. It's not the fix is not including changing anything in AI model or prompt engineering or anything like that. Okay, so I want you to notice here. So basically like zero model in this one. This is like pure infrastructure here, plumbing, etc. So for this one, it's like let's say good fleet system uses something called desired state reconciliation. In basic words, actually like just the thermostat again. So we're gonna have like redfish with patch, like redfish patch says drive this machine to this specific state, and if like you're gonna apply the same thing twice, the second one would just like changes nothing because it was already there. So that's idempotent for free by design here. But let's say for example if an action like reset is not, then if you're gonna send it twice, you're gonna reset the box twice. So even here, like pure infrastructure, like with no model anywhere, is the same question which that you've been asking this whole time. Is this safe to run twice? Yes or no? That's like the entire game, like at every single layer, no matters from the up layer of software down to the infrastructure, down to the metal side, does not matter. That's the whole game here. Like this block 2 done, like you need to know already now, like you know the 4 doors of why this could happen, and now you already know about the gate. So yeah, now let's get a little bit practical. So I'm gonna have like 4 doors plus the gate. Now the practical question which you may ask right now is like, which is like, which one of these is actually yours? And I've actually got good news here, because that's gonna save you a ton of time. So basically you've got your 4 suspects: retry, redelivery, redispatch, double trigger, all these. And here's the actual move here. So you usually don't need to figure out which door you have or which door it was, because there's no gate in front of your side effect. The fix is the same no matter which door the duplicate came through. So the first thing that you need to check is it's not about which door you have, actually is there even a gate in the place or not. So let me show you actually how to run this specific thing, well, like how to gonna have this gate. So now like this is the one move, and if you take one practical thing from this whole video, take this one. So if you're gonna go to the boundary, like right before your side effect, and you're gonna ask one question, which is like, is there an idempotency key here? Yes or no? That's it. That's the whole thing. That's the whole fix here. And basically like every agent system I've cracked open so far, like 99% of the time the answer were no. So they're just like, there was no one, and nobody even put it there, nobody cared about that, nobody even think about this thing should have exist. That what caused most of the issues. And the second you're gonna find that out, you can just like stop diagnosing, because it does not matter which of the 4 doors you already have or which of the doors actually fired here, because the fix will always be identical. You just like need to add durable check like right here before the side effects. Like you need to have durable strong gate. So you don't start with so basically to fix this you should not start with which door, and to fix this you need to diagnose one thing, which is like, is there a gate in my system, yes or no. This is like a huge time saver and resource saver for you. Okay, now if you actually like want to catch now if you actually like want to catch those like or even like just know which ones like of the doors actually happening, what you do is like you can count what the model intended against what actually ran. When intended to execute it, those like two numbers should always match, and the second they don't match you found double. And here's like the two for one. Basically like this is nice. This exact check does double duty, so it's how you spot double. It's like a double you didn't prevent, and if you're gonna leave it running for good, it's also like half the actual fix here. The reconciliation is the actual half, so it's always worth building. And honestly, like the cheapest way to first catch this is the wild is. In the wild, it's actually like usually already having something which is actually sitting in your data so far, and just like the same sum count that's supposed to be one, and if it's not one then data, that's the thing. And okay, now actually if you now like if you actually like want to know which door and one split sorts basically like you can do one split that would sort it out, so sort it out. And I want you to notice here that you never touch the model to do any of this thing. So basically you can take your two executions and you're gonna look at two things here, their IDs and actually the time gap between each of these executions. So let's say for example if you're gonna have like same ID and milliseconds apart, that's actually like a retry or redelivery. And on a queue maybe like, and on a queue like the receive count would tells you which one is actually on the spot. If it's actually like same run, it just like be redispatched later, a bit later. That's type of problem that we're gonna talk about, which is like your rerun, so the lease race. And if it has like different IDs and seconds apart with separate traces, this is actually something upstream firing twice. Done. That's like 5 minutes. You know actually your door. That's the whole diagnosis here. Super simple. Now let's talk about how you can fix them. So we already talked about you should have a gate. Now how you can fix all these doors to prevent any type of issues and make your system more robust, especially if you're planning to scale it. Now let's break this like one door at a time. Okay, so let's start by source one, the retry one. So basically here, before like retry fires and get like two charges, and after you give the request actual key here. So the coach would checks the ticket, and when the server sees the same key again, just like would hands back the first result instead of charging you again. So basically like this is the principle here. Attach a key to the thing, so it's more stable across multiple retries. And here's where actually people face plant here. So the key has to be stable. So you need to generate a fresh random one on every retry, and sorry. So basically, like if you generate like different like fresh random one on every like retry, so what ends up happening is like you gonna defeat the whole purpose of this thing. Cause like now every attempt would looks brand new and every text would look different. So the only way to protect this is like if you're gonna protect like an owner the having like same key on across the whole retries. That's like how you're gonna stop this problem from ever happening. That small detail is the whole fix. Now let's move to source 2, which is like redelivery. So for this one, before we're gonna have like every delivery would gonna recharge the customer again, and after you're gonna stop fighting the redelivery, and this makes the handler safer. So you're gonna dedupe. Sorry. So you're gonna basically dedupe on the message ID, or you can make the operation an upsert instead of an insert. That's it. So the principle here is like assume it will redeliver, and you need to make this safer, or at least harmless to your system, because for this type like for technologies you can stop the mail carrier from delivering the same thing twice. And you shouldn't even like try doing that, because that defies the whole purpose of that technology. What you should do is just like make it no matter what they do, that won't harm you later on. That won't double charge the customer, etc. And now let's talk about source 3, which is like the redispatch here. And this is the one that I wanna be actually straight with you about, because it gets oversold hard. So before you're gonna step like step gets redispatched, reruns, side effects, fires again, and it's gonna appear like durable execution, recorded step skipped on resume, etc. Okay, and after that you move the tool into durable execution. So step that already finished will just like get skipped when the run resumes, and that's what's gonna happen instead of just like running the same thing again. So the principle here is basically durable execution plus the step itself has like gotta be idempotent. That's critical. And here's the whole honest part here, because like durable execution gets sold like wow, this is magic bullet, and in reality it's not. Durable is not the same as exactly once. So if a step runs but the result didn't get saved before it crash, to just like still run again, and compensation would only goes so far. So for example you can refund the charge, that's sure, but you cannot actually unsend an email, and or maybe like some more mission critical stuff. For example, if let's say in healthcare or in military, if like people's life on the line, you cannot undo that thing. So the real move here is to put your irreversible step last, and that way like where like even like a failure earlier would gonna happen would means they just like never gonna run in the first place. Now the source 4 is about the duplicate trigger. So before we're gonna have like two triggers, two rows, nothing stops the second. And after you just like reject the second one with an atomic claim, so basically like a unique constraint or maybe like compare and set type things. So the principle here is reject the second with an atomic claim, and this is like where the word atomic comes back again. So if you check whether you've seen the thing or not, and then separately write it down that you actually did that, two of them slip through the gap in between whether they've seen it and whether it and whether like you write it down or not, because you can see it but you could have been seeing it but you didn't write it down. You could have yeah, that's the gap between these two things that failure could happen here. So that's like the case of every single time. So the solution for this is these two things should happen in one operation. So it should be like read then write, both at the like just like one operation, and just like an atomic step. So that should happen or nothing should happen in the first place. And now let's talk about the gate itself, the enabler here. So before there were no gate, no check, one intended but two got executed, and let's say appeared like idempotent plus reconcile, and now after that we're gonna have like you make the operation idempotent, you reconcile afterward to catch anything that slips, and you classify your errors before you even retry. So the principle here is idempotent, reconcile, and classify. And here's the subtle build here, and ties right back to the crux. Only like clearly transient error, like for example, the service was barely down, or it's actually safe to just retry it again. Because if we're gonna talk about timeout, it's not safe because remember, timeouts it's actually ambiguous. Because in reality they may have worked, but it's just like timeout ran before thing finished running. Um, so what you should do is you should gate that timeout behind the key first, and then it will be safe. And now let's watch the whole thing fixed here. And this like closed the whole loop from where we started. Yeah, it's already like 56 minutes so far. So yeah, the original one still come through, like still fires. That's good. And now what was gonna happen? So duplicate would come through. It was gonna hit the gate, and just was there. It's gonna just like get caught right there. So the doors are still firing duplicates. And notice here, because we didn't stop that from happening here. The doors are still open. We still have some issue here, but we have a gate. So we just like put something in the way that we just like recognize each of these doors. Just like a bouncer in a club, something like that. And now let's see what's gonna happen. So that bouncer catch the error, and that second execution did not pass to the side effect. So for this one, the intended execution was once, and the executed times were once as well. Just like step back for a second here, and just like notice what none of that was. None of it was about prompt engineering. None of it was about AI, like more smarter AI models, stuff like that. So now, like every one of these four doors that we talked about, like yeah, these ones. So every one of them lived right here in the plumbing between your request and the thing that actually happens. So I need to repeat again. None of this was about the AI model at all. And honestly, like no amount of like effort or money we're gonna spend on making the AI model smarter with more parameters, maybe adding better prompt engineering, would ever like make any like change in this situation. Yeah, so let's summarize. Bigger model does not add anything to the gate. That's the part on you. That's part of the plumbing, not about the model or the side effect itself. Yeah. So this actually like really comes down to one thing, which is like about every single action your system takes. So every side effect is either idempotent or it's just like a bug waiting for retry. That's it. And that's the bigger lesson in all of this video here. Whether like something is actually safe to run twice or not. That's actually the same question at every single layer of the trace. It's not just about AI agents here. It's about the network, the protocol, the queue, the bus, database, all the way like out to the fleet. Like, and honestly, answering this means being willing to look at all these layers together, and that's the same discipline that like whether there's a model in the system, like AI model in the system in the first place or not, because it will still be the same thing. So yeah, basically like day one the order gets dropped, day two it runs twice, both times was like the same exact thing missing. Guarantee about what actually ran here. So that's like the retry that run twice type of problem. So we discussed all four doors, the one gate that should happen, and how we're gonna diagnose and fix each of these to stop this type of issue from happening in your system. And if you're dealing with one of these type of issues right now, and maybe like different type of problems, and you just like want more personalized help, just like shoot me an email, and you can find my email in the description. And all you need to do is just like tell me what you actually see in your system, what type of system you have, and what your stack actually looks like. And I'm gonna reply with more detailed breakdown, more specific answers to your specific case. So that was the whole video. Hope you find it insightful and it helped you to solve a specific problem in your system. So yeah, it's over 1 hour now, so that's the whole video now. Take care. Bye.